In this video, we're going to take a look at Java's layout managers. Now for these examples, we're going to import from two packages, the Abstract Windows Toolkit and Swing. Before getting started, let's review some preliminaries, such as getting the content pane. Before adding any Swing components to a JFrame or JApplet, we must get the content pane with the method getContentPane. This is something like grabbing the device context with GDI methods in C++ MFC programming. Doing this gives us a pointer or handle to the JFrame or JApplet's background, so we can add components to it or draw objects on it. Then we can add items with the add method. For example, in this first example, we're coding something from scratch, just using a simple text editor. And we have a font object and a JLabel. And in order to be able to add that JLabel to the JApplet or JFrame application, we have to call the method getContentPane, pass it to a container object because that's what it returns, and then we can use the add function to add the objects one by one to the JApplet or the JFrame. Now here's how that same process would look in NetBeans. NetBeans does it automatically, or this is part of the auto-generated code when you build a JFrame or JApplet interface using the interface builder. In this case, it just calls getContentPane without having a separate container object to pass it to, and we can directly call the method add. Having reviewed the concepts of container objects and the importance of getting the content pane before adding something to a JFrame or JApplet application, let's take a further look at layout managers. You can think of a layout manager as different types of word wrap for Java components. In the same way that the word wrap feature wraps characters of text around to the next line in a word processor, layout managers wrap Swing components around the visible area of a JFrame or JApplet. Layout managers are derived from the Abstract Windows Toolkit package. Let's look at some of the more commonly used types of layout managers in Java. The first is BorderLayout. It's the content pane default and utilizes top, bottom, left, right, and center locations. The second is BoxLayout, which uses a single column in each component's maximum size attribute. The third is CardLayout, which is sort of like a deck of cards. It uses different panels at different times, displaying one component at a time. The fourth is FlowLayout. That's the JPanel default, and it displays components in a single row like word wrap. The fifth is GridBagLayout, and it uses grids of cells, sort of like an Excel spreadsheet or database tables. The sixth is GridLayout, and it makes components equal in size, rows, and columns. 7 and 8 are GroupLayout and SpringLayout, and both of these are used with GUI tools, usually with GUI designers or graphical designers. The last one, number 9, Null, is my favorite. That's no layout manager, and you simply use absolute positioning with things like set bounds and set location to specify the XY position of each component on a JFrame or JApplet. The first layout manager we'll examine is FlowLayout. FlowLayout is the default manager for panels. It adds components with natural size in a horizontal line. If there are too many components to fit in one row, it uses multiple rows. Components are centered by default. FlowLayout uses the following overloaded constructors: FlowLayout all by itself, FlowLayout taking one integer, and FlowLayout taking 3 integers. Here's a breakdown of the FlowLayout constructor parameters. Alignment is where components will be added. The default is FlowLayout center, and there's also FlowLayout left and FlowLayout right. Horizontal gap, the integer, is the horizontal gap between components, and the default is 5 pixels. Vertical gap is the vertical gap between components. The default is 5 pixels. In the implementation, we would simply add it to the container or panel where we want to use it. For example, the way some programmers do it, including NetBeans, is to simply call the method or function setLayout, and then as a parameter or argument to that method, instantiate a new FlowLayout object, like we're doing right here. As an alternative to the previously described method of setting FlowLayout, we could also do it the traditional way, in which case you would call the method or function getContentPane and assign the return value to a new container object. You would then instantiate or build a new FlowLayout object. Then you would take your container object and call the method setLayout and pass in your instance to FlowLayout, like so. Here in this example program, the very first function we're going to call is example1 FlowLayout to demonstrate the use of FlowLayout. And we're just going to call the method setLayout, and as a parameter we're going to instantiate a new FlowLayout object. And then we're going to add 5 components to our JApplet, and it's going to arrange them sort of like word wrap, so we can see how it works. So let's go ahead and test it, and we'll run the application. And you can see it adds our buttons in word wrap fashion, one right after the other. So FlowLayout is one of the more commonly used layout managers for simple components because there's not really much work to do in terms of setting it up. You simply use set layout and pass in a FlowLayout object and add your components. The next layout manager we'll examine is BorderLayout. BorderLayout is the default manager for a dialog or frame. It contains 5 areas: center, north, south, east, and west. The center area grabs as much available space as possible. The other areas consume space only as needed for their components. Typically used for maintaining a row of components in an area near the edge, BorderLayout contains 2 overloaded constructors. The first takes 2 integers, and then of course you can simply call BorderLayout by itself. Here's a breakdown of the BorderLayout constructor parameters. HorGap is the horizontal gap between components, and the default is 0 pixels. VertGap is the vertical gap between components, and like its predecessor, the default is 0 pixels. For the implementation, we simply add it to the container or panel where we want to use it. For example, here we're simply calling the method setLayout, and as a parameter we're instantiating a new BorderLayout object. Once we do this, we can add components and specify where to position them with BorderLayout center, north, south, east, or west. As an alternative to the previously described method, we could do it the traditional way, which is to call the method getContentPane and assign the return value to a new container object. We then instantiate a new BorderLayout object, and we call the method setLayout on our container object and pass in the BorderLayout object. And then once again, when we add our components, we specify where to position them after the component name with BorderLayout center, BorderLayout north, south, east, or west. In this second example, we're going to do BorderLayout. So let's comment out the first, and we'll call the second method here. And in this function, we're simply using the setLayout method, and as a parameter, we're instantiating a new BorderLayout object. We're going to create some new JButtons on the fly, and when we do, we're simply going to specify center, north, south, east, and west to show each of those locations in a BorderLayout configuration. So let's go ahead and run this, see what it looks like. And then I'll enlarge this a bit, and you can see there's center, which takes all of the available free space, north, south, east, and west. The next layout manager we'll look at is CardLayout. CardLayout manages multiple components that share the same display space. These components are managed like an array of objects or a deck of cards. It only displays one card or component at a time. CardLayout's constructor is simply CardLayout, no arguments. It uses a special form of the add method, in which case you not only pass in the container, but also a string describing which card to display. CardLayout makes use of the following methods. First displays the first card added. Next displays the card added after the one currently displayed. Previously displays the card added before one currently being displayed. Last displays the last card added. And then show, passing in the component name and the string that describes it, shows the component identified by the string y. In this example, we build a new panel object called BG for background. We then instantiate a new CardLayout object called deck. We call the method setLayout on our panel object, passing in our CardLayout object deck, and then we're going to add 3 components. Each one has a descriptive string. So in addition to adding the button, they're described by ace, king, and queen. Next, we can call the show method on our CardLayout object. We can pass in this case, the panel object, the background, and we use the string description to tell it what component to display. In this case, king, which is the second component. Finally, we use the add method, and we simply add the panel to the JAPPLET or JFrame application to display it. Back in our test program, now we're going to call the third function, and this demonstrates the use of CardLayout. As in the previous example, we're going to use a panel. So our instance of the panel will be called cards, and that'll become the background on which we wish to paint. We're going to build a new CardLayout object called deck, and we're going to call the setLayout method on our instance of panel and pass in our instance of CardLayout, which is deck, to set CardLayout as the default layout manager. Once we do that, we're going to add 3 components. They're buttons, and they're each going to have a descriptive string, because remember that CardLayout uses a special version of the add method. Once we do that, we can then use the method show on the CardLayout object up here to show any of those components. In this case, we're passing in the string ace, so that identifies the first component, and that's what it's going to show. And then finally, at the very end, we're going to add the panel to the JFrame or JApplet to get it to display. So let's see how that looks if we run it. In this case, it just displays the ace of hearts. Now what if we wanted to display, instead of the ace, the third component? We would simply change the string, and let's rebuild the project. And now, in this case, it's a 3 instead of an ace. So you can see how the string identifies the component. Also, alternatively, you can call the method first. And if I did this, let me go ahead and rebuild the project and we'll run it. Notice it just displays ace of hearts because that was the first object. The next layout manager we'll examine is GridLayout. GridLayout assigns components to a grid of cells. Each cell in the grid is the same size. Components grow to fill available area. It is typically used with projects like calculators, calendars, and chessboards. It contains the following overloaded constructors. The first takes 4 integers, in this case rows, columns, the horizontal gap, and the vertical gap, and the second would take 2 integers, describing the rows and columns. A breakdown of GridLayout's constructor parameters is as follows. Rows is the number of rows, and columns is the number of columns. Special note, when 0 is used. When the value 0 is used for rows or columns, it means as many as necessary, but both cannot be 0 simultaneously. The other two arguments, hoRGAP and vertGAP, represent the horizontal gap between components and the vertical gap between components, and both default to 0. Here in this example, we're setting the layout manager to GridLayout with the method setLayout, and we're simply building a new GridLayout object and passing it in as a parameter. In this case, specifying rows as 0 and columns as 1. Then we're going to add some components, in this case buttons, attack, defend, use, navigate, and ability. Now we're back in our test program, and this time we're going to call function for, which will demonstrate the use of GridLayout. So we're going to use the method setLayout to set the layout manager. As a parameter, we're going to instantiate a new GridLayout object. We're going to pass in 0 for the number of rows, which remember, that also means, or is synonymous with, as many as necessary. And we're only going to pass in 1 for column. So these will all be stacked in one straight column. And they're of different lengths, but just to show you what it looks like. In this case, as many rows as necessary, 0, so 5, since there were 5 components, but only 1 column, so they're all stacked on top of each other. The next layout manager we'll examine is GridBagLayout. Like its predecessor, GridLayout, it arranges components and cells, but it also has some enhanced capabilities. GridBagLayout places components in a grid of rows and columns. It allows components to span multiple rows or columns. Columns and rows do not have to be the same width and height. It uses a component's preferred size property to determine how large the cell that contains it should be. GridBagLayout uses a GridBagConstraints object to set its layout properties. This object must be instantiated and then used to set the constraints and properties of the GridBagLayout and its components. Here's a description of some of the GridBagConstraint properties. GridX is the column, and it starts at 0. GridY is the row, and that starts at 0. GridWidth is the number of cell columns component consumes. GridHeight is the number of cell rows a component consumes. IPadX is the internal cell padding for width. IPadY is the internal cell padding for height. And NSETS is the external padding for each component. But wait, there's more! weightx is the priority for distributing space among columns. The range is from 0.0 to 1.0. WeightY is the priority for distributing space among rows. Again, the range is 0.0 to 1.0. Fill specifies how to fill a cell if the component is smaller than the cell space. The options include none, which is the default, horizontal, which makes the component fill the horizontal space, vertical, which makes the component fill the vertical space, and both, which makes the component fill both the entire horizontal and vertical space. But wait, if you act now, there's still even more. In this case, anchor, which is where to place the component. And the values are first line start, page start, first line end, line start, center, line end, last line start, page end, and last line end. And I tried to put these in the position where the component would be placed if you specified that attribute. In this example, we have two JButtons. We're going to call the method getContentPane and pass the return value to a new container object, BG for background. We're going to take our BG object, call the method setLayout, and instantiate a new GridBagLayout. Now before we can use our new GridBagLayout, we also have to instantiate or build a new GridBagConstraints object. Once we do this, We're going to use our GridBagConstraints object and specify the fill as horizontal and the weight of x to be 0.5. Finally, we can add our two button components, and when we do this, we also have to use a special version of the add method and pass in the GridBagConstraints object, constraints. Once again, we're back in our example test program, and this time we're going to call function 5, and function 5 demonstrates the use of GridBagLayout. So, as before, we have two JButton objects. We're going to call the method getContentPane, and then pass the return value into a new container object. Once we do that, that becomes our background, and we'll call the method setLayout, and as a parameter, we'll instantiate a new GridBagLayout object. When we do this, before we can use it, we also have to build a GridBagConstraints object. So we instantiate that as constraints. Once we do that, we can use our GridBagConstraints object to set all of the properties that we need to set to display the component properly. So we're going to set our fill to horizontal, the weight of x and y to 0.5 and 1.0 respectively, grid y, the padding is iPad y to 0, grid width is 2, the anchor in this case to page end, and the end sets. Finally, we just need to add our components, and because we're using GridBagLayout, we use a special version of the add method. Not only do we specify the component name, but also the GridBagConstraints object as well, constraints. So let's see what that looks like if we run it. And you can see here's our two buttons, self-destruct and abort. The next stop in our tour of commonly used Java layout managers is BoxLayout. BoxLayout arranges components in one of two ways. First, on top of each other, or two in a row. When positioning components, it uses their alignment, minimum, maximum, and preferred size properties. It may take one of three orientations. The first is top to bottom. This sizes a component at its preferred height. If vertical space does not match the sum of each component's preferred heights, it expands or shrinks the components to fill the available space. It will not exceed the component's minimum and maximum size property in this endeavor. Extra space displays at the bottom of the container. The second orientation is left to right. This sizes a component at its preferred width. If horizontal space does not match the sum of each component's preferred widths, it expands or shrinks the components to fill the available space. It will not exceed the component's minimum and maximum size property in this endeavor. Finally, the third orientation is right to left, which is simply the inverse of above. BoxLayout's constructor takes two arguments. First, the container it manages, and second, the axis along which the components are laid out. Axis options are page axis, which lays components out in the direction that lines flow across a page as set by the target container's component orientation property. Line axis, which lays components out in the direction the text flows in a line as set by the target container's component orientation property. X-axis, which lays components out left to right, and Y-axis, which lays components out top to bottom. One of the interesting things that BoxLayout does is it uses invisible components as fillers. Invisible components are used as fillers and to control spacing. The three types of objects that can be used as fillers are rigid area, glue, and filler. Let's take a look at each particular component. The first one we'll examine is rigid area. A rigid area is an invisible component used to add space between other components. It creates a fixed size space between components. For example, to place 15 pixels between two components in a left to right box, you would code it like this. Simply call getContentPane, pass it to a container object, you would add the component, and then you would simply call box.createRigidArea and pass in a dimension object, in this case of 15 pixels. The second invisible component we'll examine is glue. Glue grows as necessary to absorb any extra space in its container. It can specify where extra space should go. In other words, if we put horizontal glue between two components in a left to right box, the extra space will go between the box's components instead of to the right of its components. On the other hand, if we put vertical glue between two components in a top to bottom box, the extra space will go between the box's components instead of to the bottom of its components. Here in this example, we're simply calling createHorizontalGlue to add horizontal glue between component 1 and component 2. We're a poet, and we don't even know it. The third invisible component is filler, and it specifies a component with whatever minimum, preferred, and maximum size is desired. For example, here we have three dimension objects, min size, max size, and preferred size. So, if I wanted to use them as filler, then I could simply call box.filler and pass in min size, preferred size, and maximum size for each of the components. There are alternatives to using invisible components, if you decide they're simply not for you. Alternatives to invisible components can be empty borders. These also can be used to create space around components like panels. Remember, borders are independent of layout managers. For example, to put 15 pixels between all sides of a dialog and its contents, we would create two JPanel objects. We'll call them Pane1 and Pane2. We're going to call the method getContentPane, and then we're going to use the method createRigidArea and pass in a dimension object of 15 pixels. And then we can simply call BorderLayout center and page in. Back in our super happy fun test program, we're going to call function 6 this time and test BoxLayout. With our BoxLayout, we have some J buttons. We're going to build a JList object for a list box. And we're going to come down here, add a JPanel and a JLabel, and specify BoxLayout with page access. Once we do this, we're going to add the components and we're going to create a rigid area, in this case, and specify 5 pixels, and an empty border. We're going to make another JPanel. We're going to come down, we're going to specify BoxLayout, and this time line access, and we're going to create an empty border and use some horizontal glue between our components. Let's just see what that looks like if we run it. Okay. So in this case, again, you can see banana pancakes, and here's our buttons, here's our JLabel. As we come to the end of our tour of commonly used layout managers in Java, we get to my favorite, which is Null Layout Manager, or no layout manager at all. Setting the layout manager to null allows the use of absolute positioning when combined with functions like setBounds or setLocation. Using absolute positioning gives you more control over precisely where you place components in JFrame and JAPPLET applications. The trade-off for gaining this greater precision in component placement is that the components do not adjust as well when the parent is resized or there are major differences between systems, such as default font and locale. For example, here I'm calling the function getContentPane and then setLayout, and I'm passing in null as the argument. So in this case, there's no layout manager that's being used. Because of that, I have to call the method setBounds on my JLabel to specify the XY position and the width and the height. We're finally at the last function of our test program. This time we're going to call function 7, and that examines null layout. So we call the method getContentPane, and then we call the function setLayout, passing in null as an argument. So no layout manager is being used. Because of that, we have to use setBounds, which specifies the x-coordinate, the y-coordinate, the width, and the height. And if we run it, our Blade Runner font, I'll move the JApplet background over here, but you can see x goes from left to right, so it moves over 50 on the x-coordinate, and then y goes from top to bottom down and increases, so it moves over 50 and down 3. And then the width is 190, and the height is 15. So you can see how that works. Note, all of these layout managers can be set graphically within NetBeans when using the GUI form designer with JFrame and JApplet applications. For example, we're going to add a JApplet form just to show you the GUI design tool and how we can do this graphically just by right-clicking. So in this case, let me go here and choose Other, and we'll do Swing GUI Forms. We'll do a JApplet form, and we'll call this Example. Alright, and once we do this, notice I've got the two tabs now, the source code tab and the design tab. But I can simply right-click and see how there's a Set Layout option on the pop-up menu. And I can specify Free Design, Absolute, Border, Box, Card, Flow, GridBag, Grid, and Null. All the layout managers we've previously discussed. And simply just with the click of a mouse, I can set that option. In this case, my favorite again is Null. So I would just right-click and say Null, select Null, and then I could add my components to the form. And when I do this, the cool thing is NetBeans writes the code for me. So as I'm adding the components, it writes the code down here as far as instantiating the objects. And then here, notice that it's, because I'm using null layout, it's calling the method setBounds and specifying the XY coordinate of each object. And let's say we modified that and changed it to something different. Let me go here and we'll right click and we'll set layout to, I don't know, FlowLayout. In this case, notice that, and it modifies the code accordingly. Alright, so now it's making a new flow layout, calling get content pane and adding the components that way.